Physics chapter 19, theory video 3, describing oscillations. So as we saw in the earlier three examples, they move in the same pattern, right? They start at the central point, then decelerate when it goes to the far ends, and then it accelerates when it returns to its central point. Now for example, if this is the central point and it decelerates when it goes to this point, the extreme end, if this is the extreme end, then once again it accelerates toward the center, passes this point, and then decelerates once again to come to the other extreme end, and then accelerates once again to come to the central point, and it passes the central point. So at this central point it has the highest velocity. So that is something that you must understand. Then at this far extreme end it comes to a stop momentarily and reverses the direction. So that is another factor that you need to understand. Then there are different terms that we have to that are associated with these type of movements. uh, the uh, the movement of this can be shown in a displacement time graph, and the displacement varies uh, in a way that can be described as a sine curve. So as a result, we describe this motion as sinusoidal movement. Sinusoidal movement is the motion of this graph. So as you can see, the time it takes for one single oscillation is what we refer to as period t, and amplitude is the highest displacement. The same general principles would be applicable here. Then notice that the displacement changes between positive and negative values as the object moves through the equilibrium position. So we take one direction as positive and the other direction as negative. The maximum displacement from the equilibrium position is called the amplitude XO of the oscillation. The displacement time graph can also be used to show the period and frequency of the oscillation. So obviously, the time, if you take it as time as a single unit of seconds, then how many oscillations take place per second is going to be the frequency. So the period is for the time taken for a single oscillation. As you can see, the displacement here is to this direction it is positive, and this direction it is negative, right? So basically what that means is you have taken upward movement or right hand direction or left hand side direction. You have taken one direction to be positive, then of course the other side becomes negative. The oscillating object must go from one side to the other side back again. So this is a single oscillation. It starts from one point, then goes to one extreme end, then passes the central point and goes to the other end and returns back to the central point. So that is a single oscillation. The frequency is, the equation, frequency equals 1 upon period, or we can write it as F equals 1 upon T. And from there we can take another equation for t equals 1 upon f. So these two equations you must remember and understand. Write down the topic describing oscillations. In an oscillation, a common pattern of movement can be observed. Movement is fastest at the center or the resting position. Decelerates as it goes to one extreme end, stops momentarily, and accelerates as it comes to the resting position, and this cycle continues to repeat. And leave a line and write, when illustrated on a displacement time graph, we obtain a sine curve as the graph. Therefore, the motion is described as sinusoidal, sinusoidal, sinusoidal. The amplitude and the period along with the frequency can be illustrated as well as calculated using the graph. Leave a line, put a star and write down maximum displacement from the equilibrium position is called the amplitude XO OX0. And please write down these two equations. Frequency equals 1 upon period, OF equals 1 upon T, and T equals 1 upon F, period equals 1 upon frequency. If you understood, please do question number 3. If you did not, please ask me questions.